Hello everyone, my name is Jason Kim. I'm a software engineer working for a company called Coupang. Coupang is a Korean e-commerce company and I am working on building an ad platform. My talk today is titled Big Data Engineering with Node.js. When you think about data engineering, people don't typically associate Node.js as the programming language as a choice. People think about the two big programming languages, Java and Python. But I would like to share my experience with dealing with the problem in data engineering that I solved with Node.js. So in this talk, I'll get into what a typical data engineering problems are, what is data engineering, and in the second section of the presentation, I'll talk about how I've used Node.js to solve the problems that I've encountered. So what is data engineering? It really boils down to preparing the data in a way that people and services can get to it, use it easily. When you're dealing with small sets of data, this problem is fairly trivial. You can load the data onto database and your job is done. But once you start to have a much bigger set of data, everything from getting the data and cleaning the data, loading the data in a useful place, all these things become a challenge. So what was the problem that I was dealing with? I mentioned that I worked in the space of advertising. So there's tons of data in advertising. And we use AWS as the ecosystem for building our systems. So we had a lot of advertising data that are being flown into S3 as flat files. These are obviously dirty files. They're not immediately usable. So you have to do some work so that this data becomes more usable and retrievable in a certain other place. There's also not just advertising data, but purchase data that advertisers are interested in because they want to see how has my advertising been done. So purchase is what advertisers are interested in. So purchase data is also important. I'm building reporting system as well as the data pipeline, and I would like to use the advertising data, but in its state, it's unusable. Also, there's need for analysts who want to learn about the data and predict how the business will do a couple of months down the road, years down the road. So given some of those problems and needs, what is the solution that I came up with? It's a very classic pattern in data engineering. I was building an ETL system. ETL stands for extract, transform, and load. Extraction refers to the action of retrieving the data from somewhere securely. Transformation is the step where you clean the data, you enrich the data by merging different data sources, and sometimes, did I mention cleaning? There's a whole bunch of, say, user queries that people enter that are just gobbledygook. You gotta get rid of those. So yeah, some of those things can be referred to as transform. And finally, once you have the clean data that's usable, you want to load that data somewhere useful. Typically, it's database, so you want to load that data. This graph here hopefully gives you an idea of the growth pattern of the data that I was dealing with. This is a graph of number of impressions per day. And the day duration here is 5 months ago, 2019, April. I don't have the exact number for other reasons, but what I just want to show you is that the data has doubled in the course of 5 months. And the pace at which it's growing is pretty steady. It's not going to get lower or steady. It is going to approach billion rows per day pretty soon. And some more context about the size of the data We are now around 100 billion rows, and the size of the data that we're dealing with are at around 20 terabytes. Again, there are many different types of events and metadata that describe advertising objects and advertisers. All those needs to be cleaned up with its own business rules, and the number is growing. So with the growth of the data comes new challenges. I think I mentioned a little bit earlier that when you deal with a small set of data, the problem isn't as difficult. But the same problem of retrieving the data, cleaning the data, loading the data becomes much more difficult as soon as the data sizes are bigger. For example, transforming. Before you could, say, load the entire data set into your memory, and that would be fine because you have, say, 1,000 rows that you have to transform. But as soon as you start dealing with several million rows per second, that's a new challenge that you cannot just load the entire data set into memory. Same for storage and retrieval. Once you have billions of rows in a table, simply querying with the SQL that you used to use doesn't work anymore. So you have to optimize your query in SQL, you have to optimize the table. Think about many different ways you can retrieve the data. Maybe you can reduce the number of rows you have to query. A lot of different creative solutions need to be thought about in order to solve those problems. And of course, you have to do all those things while keeping the data in a secure manner. With all those things considered, this is the solution that I came up with. It's obviously boiled down to very discrete things, simplified, but I hope that this will give you a good picture of what I've delivered. I've mentioned that earlier, the dirty data is coming to S3. So the red structure at the bottom is the S3 bucket. It contains both clean data and dirty data. And the journey of the data starts with the top left corner, the Lambda functions. These guys are the ones that gets triggered with certain events and does something very simple. In my case, it will get triggered with time. Different types of advertising needs to be ingested at different times. Some are real time, some are daily, some are hourly. And it'll just create a HTTP request to a ETL system that I built. It's called Morningstar. Morningstar has a load balancer that will receive the HTTP request. It will evenly spread its load to different EC2 instances. The EC2 instances can also scale up and down. They're not static in the number. This is because the data sizes are always growing. The data also changes in volume during the day. There's the peak hour, there's the less busy hours. And the EC2s are auto-scaled based on the CPU usage because the transformation step is the bottleneck in my system. So once the load balancer receives the HTTP request, it will send that request to one of the EC2 boxes. And the EC2 box knows what kind of job it has to perform, where it has to get the data. So it grabs it, cleans it up, makes it into something usable, uploads it back to S3, and then we load that data to Redshift, where it can be used by people, it can be used by other systems, it can be further aggregated to make a more transactional oriented tables. So all those things are done from Redshift. So all these problems that I've worked with, why is it that I chose Node to do it? Because Node is not typically used for data engineering. I mentioned that there is Java and Python. People have been using these two languages very happily, working with data systems. Why Node? The way I thought about this was that transformation is the bottleneck, as I mentioned. So I needed a programming language that's fairly fast. Java is good at that. Python is not so good at that. Node sits somewhere in the middle. That's fairly performant as Java. So that was a plus for me. So that met the minimum bar at which I chose that I was choosing a programming language. And the real pull for me was that it has many great NPM packages. They are well documented. Some are not so well documented, but many are. Many are great to use. They're always constantly updated and maintained because of so many JavaScript developers out there. And the Node standard module library is just awesome. They're really well documented. Many people have used it. Many people have written blog posts about it. So there are a lot of smart people who solve some of the problems that you are trying to solve now. So you can learn from the better, people who's done these things before. And I like to write JavaScript as a programming language. I noticed I like it much better than Java because it's less robust. You don't have to use IDE. That could be clunky. I just use either Vim or VS Code, and that worked perfectly for my use while writing JavaScript. So from now on, I'll talk about some programming patterns that I've used that I felt were really good with the work that I was doing, and some other tools that I found really useful in Node.js. So we do a lot of asynchronous programming in data engineering. So you're making requests, you're downloading files, uploading files, parsing large set of data. You cannot do this in synchronous manner, right? You'll be blocking the process and it won't work. So for that reason, you have to do asynchronous programming. We know of two ways other than async await. We know callbacks, we know promise chains. Callbacks, if you're doing a couple of callbacks, that's okay. But as soon as it becomes a little bit more difficult, it'll start to span horizontally. It gets fatter. You have what you say nested callbacks, right? So reasoning callbacks become much harder and harder. That problem has been solved with promise chaining. So promise chain, when you start to write it, it becomes more vertical, so it's easier to read. However, it comes with two other problems that I noticed. Precise error handling is more difficult because the catch block that is responsible for catching promises in a chain now has to determine where has that error occurred in the chain. So if you had 5 promises in a chain, that error could have come from any number of these promises. So that is a little bit of a problem. Another problem is if you start using if-else statements within the promise chain, you end up having nested promise chain, which has the same effect as nested callbacks. You start to have a fatter code yet again. All these problems actually are solved with async await pattern. So you have a much more vertical view of your code that is easier to read, easier to reason with. You have a better handling of errors because you can write try-catch blocks wherever those asynchronous code are running. And finally, you have a much nimbler control of your code. If-else statements are just fine because you write async await code as if you're writing synchronous code. Stream library. Stream library is something you absolutely need to use when you do data engineering. This is because you will eventually deal with data sizes that are not immediately loadable to your system anymore. So in order to avoid exhausting your memory, you will have to use stream library. Having spent time transforming terabytes of data, I noticed that when something goes wrong, it's never stream library's fault, it's always my fault. So stream library is very reliable. It works well with async await pattern too because you can write the promise wrappers around those events being fired, and then that works perfectly fine with async await. Some other tools that I really liked. Child process. You need it because in data engineering, there's a lot of different command line tools that you would want to use. Obviously, common ones like cat, those things you have to use it with child process, but more rare ones, JQ, which is used to transform and parse JSON. Parallel, you need it for running command lines in parallel, and finally, Hive Beeline client. This is the only way I could talk to Hive in Node. All these things run on command lines, so you need child process for that. Reading and writing file, you have to do it, so you want FS. And zlib is used for gzipping and gunzipping file. Well, again, when you're dealing with small files, and you're transferring the file over the network, that's not a problem, right? You have, say, 2 megs, 3 megs transferred, that's fine. But once you have to start transferring gigabytes of file every minute, you'll want to reduce the size so that you can transfer the files much faster. That's where zlib is very useful. Obviously, Node.js is not perfect. There were some downsides of using Node.js that I thought were worth mentioning. First one, big one for me, was that it lacks a up-to-date, reliable Hive client. Hive is a data engine that is used to query very big data. And the way I had to make this work in Node is that I had to first install JDK, which is the environment that you need to run Java applications. And I installed Hadoop and Hive, which are the dependencies for Beeline. And then that gave me the Beeline command line client. The way I used this client was that, once I want some data from Hive, I'll use this command line client, write the data into a file, and then read the final file, and I'll get the data that way. So it's a really convoluted way of getting the data off Hive. I wish that someone worked on a better solution. Another annoyance that I had to deal with was that because I like async await so much, I have to work with promises. If you have callbacks, which some older packages still use, I had to write my own promise wrappers around them. There is a function called promisify in util library. However, not all callbacks are written the same way, and I noticed that there's some unexpected side effects of using that. So to be sure about what I'm using, I decided to just write all the promises myself around those callbacks. So that was a little bit annoying, but I think that it's not a deal breaker for me. So that concludes my talk. I hope that this has given you some idea on what it would be like to work on data engineering problems. I know that JavaScript is amazingly useful for obviously writing web applications, Node services, and even client applications with React Native and things like that. But there's also data engineering problems to be solved with Node. So that concludes my talk. Thank you so much. I'll take some time. Yes.
Do you have any libraries you can share that so much work?
Oh, interesting. I don't have any open source libraries written out of it. I think that I could write a Hive client finally that could be more ergonomic. But no open source libraries out of this work. Yes?
Did you end up using anything like data visualization as part of this?
Yes, so I actually work on reporting application as well, and that application is very heavy with data visualization. So we use something called high charts that works well with our React application, and we have tons of pie charts and colors and bubbly things. Yeah. Yes.
Now that you've built Morningstar, your ETL system, what's one thing you wish you would have known when you started it?
Oh, interesting. One thing I wish I had known. Oh, I wish I had. I think that Redshift has really great uses for many other people. But I think I would reconsider how I would use Redshift in my experience. It had some pain points of things like it's a Postgres flavored database that doesn't have all the functions that Postgres provides. So there's been a lot of confusion using Redshift. Because it's like a closed source application, you cannot really dig into optimizing it very well. Also, it comes from the fact that the documentation is actually not up to date. So some of the instructions that Redshift has given me are contradictory in some parts of the doc versus some others. So I think Redshift would be something I would reconsider. Yes?
If you're ingesting data into your database, how do you choose to partition your data for transfer?
Yes. So the main partition happens at the load balancer level. So I talked about how the jobs are triggered based on time. So the request, when it hits the load balancer, it would randomly spread its load to the EC2 instances. So that's definitely an area where I could optimize where EC2 instance, there could be some service discovery where an EC2 instance could say, hey, I'm really busy doing 10 other jobs, don't give me the requests, give it to someone else. And then load balancer could be smart enough to say, oh yeah, send it off to this guy. But right now, what I found was that when you randomly just spread the load to EC2 instances, that's been sufficient as a spreading of the load. And within the transformation, I also split up the file. That really speeds up the JQ process of transforming the JSON files. That's another way I have been able to split up the workload and transform the file concurrently. All right, I think that's it. Thank you so much.